We're going to check Monday's daily math. For the first question, you're comparing the numbers 127,489 and 127,874. So when we compare numbers, we always start in the greatest place value. We have 100,000 in each of those numbers, so we have to go to the next, to the 10,000s. There's two 10,000s in each place value, so I'll move on to the thousands. I have 7,000s and 7,000s. So I'm going to go to the hundreds. I have 400 and 800. I know 400 is less than 800, so the correct answer is less than. The next question, you have 2,843,928 and 3,999,487. So once again, we're starting in the largest place value since we're comparing the numbers. I have 2 million and 3 million. I know 2 million is less than 3 million. So once again, the correct answer is less than. Next, on number 5, I'm finding the sum. So I'm going to add 892,422 plus 54,770. I made sure to line up my place values. If you notice in the first number we add, I have my largest place value is 100,000s. In the second add-in, the largest place value is 10,000s. So I have to make sure that I line those up correctly. I start adding at my ones. 2 plus 0 is 2. 2 plus 7 is 9. 4 plus 7 is 11. I'm going to carry the 1. 1 plus 2 is 3. Plus 4 equals 7. 9 plus 5 is 14. Regroup the 1. And 1 plus 8 is 9. So the sum is 947,192. The next question, there are 22,456 pine trees in the park. The park workers are going to plant 6,478 more trees this year. How many trees will there be when they are done? So if they're starting with 22,456, they're planting 6,478 more. I know I'm going to add those together. So 22,456 plus 6,478. Once again, we're making sure that we line up the place values correctly. 6 plus 8 is 14. Regroup the 1. 1 plus 5 plus 7 is 13. Regroup the 1. 4 and 4 makes 8, plus 1 more is 9. 2 plus 6 is 8, and 2 plus nothing is 2. So the answer is 28,934. There will be 28,934 trees when they are done. Next, I'm listing the first 5 multiples of 18. So when I'm listing multiples, remember I'm skip counting, or I'm thinking what can be when I multiply any number times 18, what do I get? So I'll start with 1 times 18. And we know that that's going to be 18. Then we have 2 times 18. If I do 2 times 18, that's going to get me 36. So then I'll do 3 times 18. And that's going to get me 54. 4 times 18, so 18 more than what I started with. 72. And 5 times 18 is 90. So 18, 36, 54, 72, and 90. Number 8, I'm listing all the factors of 18 in increasing order. So whenever I list the factors, remember I'm thinking about numbers that multiply together to equal 18. So we always start with 1 in itself. I know that 1 times 18 equals 18. Next, I'm going to go to 2. I know that 2 will be a factor of 18 because 18 is even. So 2 times 9 equals 18. Next, I'm going to try 3. I know that 3 times 6 is 18. Now I'll try 4. Is 4 a factor of 18? Can I multiply 4 times any number to get 18? If I skip count my 4s, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. And 4 times 5 is 20. So 18 does not have a factor of 4. I'll go on to the next number, which is 5. 18 does not end in a 0 or 18 does not end in a 5 or a 0, so 5 cannot be a factor. And then we get to 6, and I already have 6 listed as a factor, so I'm finished. The factors of 18 are 1, 2, 3, 6, 9, and 18. So since 18 has more factors than 1 in itself, it is composite. Remember, a prime number has only 1 and itself as factors, and a composite number has more factors than 1 and itself. Next, I'm completing the pattern. I have 1, then 4, then 16. So remember a couple weeks ago we did this funny looking little machine. We called it a function machine. And we said that when we're thinking about patterns, I can put any number into the machine. Something's going to happen to it that's going to be our rule. And then we'll get another number. It's going to change when it goes through the machine, and we'll get another number to come out. So if I put in a 1, something happens to it, and I get 4. I put in a 4, something happens to it, and I get out 16. So I've got to figure out what that pattern is, what's happening to that number. So let's see, to get from 1 to 4, I could do 1 plus 3, that would equal 4. But if I put in 4 and I add 3, that does not get me 16, so that can't be the rule. So I know it's not going to be addition. Oh, I know I could do 1 times 4. 1 times 4 gets me 4. So let's try it with the next number. 4 times 4 gets me 16. So I can see that that's going to be my rule. So now I'm going to put in 16. So I've got to do 16 times 4. I know that 10 times 4 is 40. 6 times 4 is 24. So 40 plus 24 is going to equal 64. All right, so now I'm going to put that 64 in to my machine. And I'm going to have to multiply that times 4. I'm going to multiply 60 times 4. 6 times 4 is 24. I'm going to add my 0 at the end. 4 times 4 is 16. So then if I add those together, that gets me 256. So this is going to be the last one. 256 times 4 200 times 4 will be 800. 50 times 4, I know 5 times 4 is 20, and I add a 0, so that will be 200. And then 6 times 4 is 24. So if I add all those together, 800 plus 200 gets me 1,000, and I have 24 left. So 1,024 will be the next number in the pattern. So my rule we already figured out is we're multiplying the previous number times 4. All right, next we're naming the fractions. So if I look at this first fraction, I can see that I have one piece shaded. So that's going to be my numerator, or the number on top. And in the whole thing, there are 2 equal pieces. So my fraction is 1/2. I have one shaded part, and there are 2 parts in the whole. Next, I have 2 parts shaded. So I'm going to write 2 as my numerator. In the whole thing, there are 4 equal pieces. So that fraction would be 2/4. But do you notice anything about 2/4? We'll come back to that in just a minute. Let's go ahead and name the fraction in number 14 in this last question. In this one, I have 1, 2, 3 parts shaded. So my numerator will be 3. In the whole thing, there's 6 equal pieces. It takes 6 equal parts to make the whole. So my fraction is 3/6. Now if we look at that, we notice the whole rectangle that's split into the equal parts is the same size in each of those. And if you notice, you have the same amount shaded in each one of those fractions. So even though there are different number of parts and different sized parts, we still have the exact same amount shaded. So we call those equivalent fractions. We could say that 1/2 is equal or equivalent to 2/4, and 2/4 is equal or equivalent to 3/6. They all represent the same amount, even though in the bottom 2 fractions we have more pieces, so each piece is smaller. If we look at the shaded portion, we still have the same amount. Okay guys, make sure that after you've checked your daily math, you're going to do your Zern Module 3 Lesson 1. I've got everyone set to start at Module 3 Lesson 1, even if you had not already finished Module 2. So you'll be exactly where you need to be today when you log into Zern. Remember to click Sign In with Google. After you've done your Zern lesson, you'll need to watch my Module 3 Lesson 1 lesson video. And then after that, you'll need to complete the problem set and the exit ticket. Hope everybody has a good day.